Hi, folks. What's my mic? Hi, there we go. Hi, folks. I'm Sam. Welcome to the 2025 Technical Designers Toolkit talk. I'm going to go really fast so I don't cut into your lunch because I need you to eat too. But I'm going to start talking about technical design. So I am a senior technical designer at Epic. I'm on the technical content team. We do things like Stackobot, Cropout, Project Titan, the new templates and template variants for us. Also, Project Parrot was us, working with Secret Dimensions. So I work across a wide variety of projects at Epic. Prior to that, I worked on Lyra. Prior to that, I was a game developer for about 25 years, so pretty decent experience. And if you want to talk to me about any of that stuff, I will be in the Dev Lounge this afternoon. Come by, say hi, I will talk to you about anything. Today, I'm here primarily to talk to you about technical design. So I'm going to stand here behind this computer and talk about technical design. So there is no one rule of thumb for tech design. Generally, it is a variety of different roles. But I'm going to talk about the different buckets we tend to fall into. Excuse me while I play with my phone while talking to you. But what we are doing is we define standards and enforce them, which, as you know, artists and designers love it when you enforce standards. There's nothing they love more than me going, no, your door isn't the right width. No, you cannot build things in a construction script. All of that kind of stuff. So we enforce standards. We do prototyping and R&D, feature evaluation and implementation, tools and support, and build health. So I'm going to talk about all of those within the context of the work I do at Epic. Having worked across all these Epic projects, I end up with a pretty decent knowledge of design workflows in Unreal. And this talk today is really designed to share stuff where I went, I didn't know you could do that, with you. And as caveat, there may be some stuff in here you already know. If so, awesome, congratulations. I think everyone should know some stuff, and not all of this is new. Some of this is existing features. There is also new future-facing workflow stuff. But if you do know something, I apologize for telling you something you know, but feel good about yourself. The idea is the more we as a group know, the further we go, the better we do. So at this point, let's dive in. And also, just so you know, I have a bunch, because I'm going so quickly, I have a QR code at the end that links to reading material for everything I talk about. Because the idea is I want to get you thinking about all these things, and then you go and tech design and read the documentation and do an implementation and learn. Really, I am here to get you inspired and educated. So I'm going to play. What do you see? So you may recognize Stackobot. It's Stackobot. Say hi, Stackobot. You probably don't recognize this landscape. Can we turn the sound off? Here's some really nice music, too. Actually, if it plays in the background while I talk, it's kind of cute. But what you probably don't recognize is the landscape. And this is the world where I'm going to build my demo. And right now, it's pretty small, right? There's not much to it. That's why we are going to talk about world building first. So world building is obviously something that we do in Unreal. And first thing I'm going to talk about as a tech designer is grayboxing, which is we have modeling tools for grayboxing. Here's a feature you probably know about. If you don't, you probably should know about it, which is cube grid. Cube grid is what I use for all my grayboxing, simply because you can define your grid size, standards, and you can use it to very quickly knock out a shape. So you can do that, you can do that. So when I was building out these little islands initially, they were all just sort of big gray cube grid boxes. It creates a static mesh that you can then, duplicate across the world. Thing to note with cube grid is because it is creating an actual static mesh, if you modify one, it's going to modify all of them. So I didn't modify that one, moving on. However, new exciting thing to note. When you are working with cube grid, if I go here and I show you my player collision, or that's my visibility collision, my player collision. Come on, player collision, show up. There you go. There is no collision on that cube grid mesh. That is a problem, right? Now, there's a bunch of ways to do it. And in the past, you may have gone to the mesh to collision thing in the modeling tool and created something like this, which is not very useful, is it? It's just a big box. So we have added something called convex decomposition to mesh to collision. that uses multiple convex hulls to generate collision, like that, proper collision. So beyond gray boxing, it is really useful if you have an asset with bad collision. You don't want to just use complex as simple because that's inefficient. You want to build clean collision. Use the modeling tools and at least short-term knock out good clean collision for your work, and your game will run better. And if you're doing anything with physics, the physics will be much happier, and so on. Don't want to linger on that too much, but yeah, mesh to collision, convex decomposition, use it. Okay, next I want to talk about packed level actors. So this is something you probably have heard of or used. Hopefully you've used. A packed level actor is what I think of as a future-facing workflow, which is what I mean is if you start in Unreal 4, you have a bunch of methodologies you probably use. Not all of them are really particularly applicable to Unreal 5, especially at this point. Packed level actor is the best, cleanest way to get a pre-built mesh assembly into your world in an efficient way. What it does is if you right-click on something and go level, create packed level actor, and you have a bunch of static mesh is selected, it will create a level with all those static meshes in them. It will reference it in a blueprint, but in the blueprint, they're all instant static meshes. They're hyper efficient. The reason you want to do this is a static mesh actor is not efficient. If you fill your world with thousands of static mesh actors, you're paying the cost for them being an actor, not just an instant static mesh. If you've seen my colleague Ari's great hitch hunt talk, he goes into this in great detail. I have a link to that in the talk notes. But packed level actors get you a much more efficient way to create your static mesh assemblies. Now, there is a way to go further than this, which is the PCG framework. Sorry, I'm moving very fast. I'm happy to talk to you about stuff afterwards. But the PCG framework. So the only packed level actor I have is this little podium. Everything else here, except the landscape, which is just a landscape with a nice WPO material, is PCG. So people tend to think of PCG as mesh scatter, which it definitely can be. But it is also, for me, a future-facing workflow that replaces construction scripts. If you've been working in construction scripts in the past, then you probably know, you've probably built things where you're like, in the construction script, create instant static meshes, do this, 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 based on user inputs. So your designers have tools to build stuff out. Do that with a PCG workflow, especially in 5.6, at which point it has been optimized significantly. And you will see significant performance and workflow improvements, meaning when you hit play, especially in editor, you don't have to wait for all those construction scripts to execute. For instance, I mean, obviously these islands are PCG. They're a little fancier. But these plinths, these platforms, they're also PCG. And they are scalable. So if I stretch it and I regenerate it, suddenly I have this platform, and what it's doing is, if I debug it, let's see if I can debug it. What it's doing is basically using PCG to determine, if I go down to the PCG component, I will be able to show you the actual grid spawn thing that's generating it. It's this tiny little set of PCG nodes. What it's doing is generating a rectangle, going, what's the interior, what's the exterior, what are the corners, and then spawning the appropriate meshes for that. So there's nothing randomized here. We're not doing the PCG mesh scatter thing. We are just generating a mesh that is much more efficient than construction scripts, and you should be doing that. You can also use PCG. I'm going to start building out the landscape while we talk. OK, that's like that. So you can also use PCG to build out other things that you would previously do in a construction script. So I'm going to make this a bit bigger. There we go. And then I am going to drop this icosphere container onto it. So this is also PCG. And this is where I'm getting into the design side of things. This generates this dome through instant static meshes, so it runs really well. However, if you're a designer, and I'm a designer, you probably want to determine where exactly people can enter-exit the zone. So if I drag this exit point, let me zoom in a little bit so I'm just not doing something too weird. OK, drag that over here. Then suddenly, there's an exit point. If I wanted to add a second one, I could create a second exit point right here. And all this is doing in PCG, if I open up the graph that is generating it, is taking that exit point, which are actor properties, use the getActorProperty node, copying the attributes, and subtracting them from the grid that generates the DOM. So suddenly you can create configurable PCG that your developers can use very cleanly to build out spaces that run efficiently. So this is an important thing to know. If you're still using construction scripts, it's time to move on. Let's move to PCG. And then finally, I'm going to talk about these islands a little bit. Now, these were built by a tech artist, not me. I'm not going to take credit for my colleagues' work. But these are hyper-configurable. So if you go to the PCG component here, you'll see that they have a ton of parameter overrides. So yeah, you can, as a developer, go, I want a bigger island. Come on, give me a bigger island. There we go. You can play with the scale. You can play with the subdivisions, so you can make them denser. And then we've included logic to say, like, put something on top, take it away. Are there floating rocks underneath? So again, artists or designers can use this PCG without having to build the PCG themselves. My advice is either you or a tech artist build the PCG and then give it to your team. So that actually leads to my next point before I get into another PCG thing, which is how on earth do you get people using stuff that you want them to use? So this is a little older. This is the actor palette. It's a plugin. And what that lets you do is reference another level. Look at that. That has all of the content that you want your developers to use. Because one of the challenges I find is that people don't know things exist, and they build them themselves in a less good way than you have already built them or your team has already built them. So here, I have this actor palette. It is a level, and then I can just click in there, click here, and bam. Suddenly, I am dropping assets directly into the world. And you can see my PCG there. I got my camera logic there, all kinds of fun stuff. So actor palette is something that your team should be using, especially if you're working with a large team of developers of varying experience. You don't want them to go wild and don't go completely out of bounds. You want them to use the stuff that you told them to use. So actor palette. So the next thing I'm going to talk about with PCG before I move on, I apologize for talking as fast as I am, is PCG for gameplay stuff. As in, I created this little PCG pickup spawner. Where did it go? So this, let's just drag that up a little bit so we can see it, this is absolutely something you would have done on a construction script in the past. It's a spline. You drag out the spline, and it spawns pickups along the spline, and then we have settings for distance, offset, and so on. And I'm going to show you, and so, when developers laying stuff out, giving them tools to more quickly lay stuff out using PCG makes life much easier. And if you look at this PCG graph, look at that. That's it. That's the entirety of it. Get the data of the spline, transform the points, and spawn actors. Simple as that. So you should be using PCG as part of your workflow. Otherwise, you can run into all kinds of fun problems, and you'll get a much more performant, cleaner set of work. All right, let's move on from that. OK, I'm going to delete this pickup spline. I'm going to hit this tool here, and I am going to bring something up on my phone real fast. OK, so PCG is really important. I am at this point going to go PCG, use it, and move on. There are some really, really good talks on PCG. I recommend Chris Murphy's A Tech Artist Guide to PCG. It is linked in the talk notes. Use that, build stuff with it. The next thing I want to talk about is level instancing. Because even though, we're using one file per actor, we're in world partition, we also are still going to run into issues where developers are stomping on each other. People shouldn't be working directly in the main world, like I am here. Instead, you should be working in a level instance. So, it's as simple as creating a level instance by selecting the things you want it to be a level instance and using them. Whereas a packed level actor can only take static meshes and will ignore everything else, a level instance can take whatever. And if you've worked in Unreal 4, this may sound similar to adding sublevels to your main persistent level. And there is a couple differences. The main one being, well, one, they're more efficient, but two, as it said, they're instances. So I can drop in all this content as a level instance, and I can drag it around. So if you want to dynamically rearrange your game world, say, It's not nearly as painful if you're using level instances. The other thing you can do with level instances is duplicate them. So you can have as many instances of you as you want. So if you have interesting gameplay setups, combat setups, all kinds of things like that, put them in a level instance rather than in the main world, and then they can be reused elsewhere. Especially you can put logic in that matches them to terrain height and so on. Then your designers can go, OK, I love this combat encounter. I can drop this in 8 different places. It will be fun. It will work. Level instances are your friend. Next thing I want to talk about is data layers. And let me bring up my data layers window 1 second. There we go. So data layers are a way to organize your content, which in the context of world building is really important. So there are 2 kinds of data layers here. There are runtime data layers, which you can load in using Blueprint or C++, load and unload, much like you would with a traditional sublevel. And that is what I've used for my slides. They are a runtime data layer that just is unloaded by default. So when I hit play, slide isn't there. Happy music, but no slides. You can also create editor-only data layers, which are great for organizing, say, design content versus art content versus engineering content. So people aren't standing on each other's toes. They don't even know that those toes exist. I'm not going to spend too long on data layers because they're a known thing, but you should be using them. All you need to do is create a data layer asset and then create a new data layer with that asset in the world. And then it can be runtime or it can be editor only. The last thing I want to talk about in world building before I move on is navmesh stuff. And so you're thinking, navmesh, that hasn't, outside optimizations, improvements, not a lot has changed with navmesh since, Unreal 4. And that is to a certain degree true. However, navlinks. How many people have hand-placed navlinks all over their game world? How many people really hate doing it? I hate doing it. I worked in multiple open-world games in Unreal 4, and anytime there was art direction that changed layout, suddenly my navlinks had to be replaced because they are the things, for those who don't know, that join multiple nav meshes together. So your NPC knows, if I jump off this platform, I will land somewhere I can move. However, if I select my recast, and then I go generate navlinks, look at my navlinks. Watch me move this around. Navlinks without you having to manually place them. So this can save you hours, if not days of time. And what it does is it uses the jump down settings from your project settings for navigation to define how the navlinks work. So as long as you set it up there and then just check that box, suddenly you're generating navlinks. And that is my world building stuff. There is a lot more there. There's a ton of documentation, all of this. Please read it after the fact. I am happy to answer questions on it too. So the next thing I want to talk about is editor tooling, because I want to move as quickly as I can. So editor tooling is something that as a tech designer you are probably somewhat familiar with. And I want to talk about our scriptable tool framework. So I showed you modeling mode earlier. Modeling mode uses the scriptable tool framework to build out all those tools, and then we have made that available to you as a plugin so you too can write your own tools. So in this case, I have written a tool. It's under scriptable tools, where all your scriptable tools live. There's a pickup spline pointer. So this isn't the magic trick. This is just a thing, like my colleague Chris did one of these in 2023 at GDC. Lets you, because you don't want to drop in my PCG pickup spline and then manually arrange the spline to put the coins in the right place. That isn't fun. You just want to paint it in. And if you cancel, it goes away. What's different between this and the one Chris built is it uses our editor scriptable modular behavior tool settings. In the past, if you wanted to create a scriptable tool, it was very discrete. Meaning if you wanted a drag and drop tool, you would create one based on the drag and drop tool and just put your functionality in. These are modular, meaning, yeah, we're talking about blueprinting and tools now. If I want to add click drag behavior, I just add click drag behavior. So let me right click here and type behavior. Add click drag, double click, mouse hover, mouse wheel, and so on. So you can create a really complex tool within the modular tool, within scriptable tool framework without doing much extra work. So this is something that came in around 5.5, so not everyone's familiar with it. But if you are building tooling in the editor, in scriptable tools, you should be using the modular behavior tool. And this is how it works. You add that, it creates event bindings for the various parts of, in my case, click drag. And then you just drag off them and create events, which I've linked to functions. So in this case, the tool, when I start dragging, I just do a line trace down to hit terrain. I spawn one of my pickup spline actors, reference it, clear its spline points, set its draw debug so you can actually see what you're drawing, and then go. And then as it updates, all I'm doing is line tracing down as you drag. And if you're far enough away from the previous point, I add a new point to that spline. That is the spline that is in the PCG blueprint. And when you release, I add a final point, and then I just tell PCG to generate, clean up and generate. So it's very simple to create a click and drag tool that PCG can use to generate stuff. If you wanted a bunch of additional functionality, say you wanted to scroll the mouse wheel to set the distance between the coins, stuff like that, you could very easily do it. So scriptable tools are your friend. And in this case, I'm going to do something that I don't want people to do, which is I'm going to paint in that. And then I'm going to do this badly, do something what I call a bad designer trick, which is things designers do that you wish they didn't, meaning things I do. So if you delete the spline, but not the orbs, there's all these unparented orbs just like floating around. You might not want this, especially because then it might clash with other stuff that has been hand-placed. And one of the fun things about PCG is anything spawned by PCG gets a PCG-generated actor tag on it, so you know it's PCG-generated. And then you could write a tool that says, makes all of the ones that are unparented go away. And then you can put it in your toolbar, or you could put it in your pull-down menu. How does that work? Very simply. So these are my tools. And the first one, I'll do the toolbar one, because that is a little bit easier. I've created 3 toolbar tools here: shortcut to game elements, shortcut to physics elements, and that cleanup tool. How do they work? Well, let's look at the pickup cleanup one. It's very simple. In the event graph, we basically, when we run the tool, get it, add menu entry object. And then if you look at the class defaults and scroll down data, I'm using the user toolbar, level editor toolbar user. You can find out what the toolbars are called from the widget reflector if you haven't used that. Then I named it PCG cleanup, gave it a label and a tooltip. And then on execute, it just runs this function, which is my let's find all the things that are PCG generated and do not have a valid actor that they're attached to and delete them. It means that I don't delete anything hand-placed, but I do delete orphaned PCG. Very simple. How do I do it? But how do you do it, Sam? In the pull-down menu. Same way. Basically, I create something called design menu. Look at that. It's exactly the same. If you look at the data, all I'm doing is I'm creating in the level editor main menu, which is this up here, or this up here, I'm creating a menu named design tools. And then, come on, mouse. There we go. To add stuff back, to add things to that design menu, all I do is this is exactly the same as the other one I built that's like just an icon, only if you look at the class defaults, it's level editor main menu, design tools, named after the design tools menu I defined. So suddenly you can create design tools that all your designers can use, or your artists or whoever, without having to do stuff manually. So one thing I want to do is, the last thing I want to show you with this, is you're going to need to tell Unreal that those exist. That's in your default editor per project user settings. That is a mouthful. Let's open that in Notepad. And that just, thank you, Notepad, for telling me how you work. OK, and that basically, these are all utilities, the editor utility blueprints. And all I have to do is tell it, OK, run these scripts when I start up. Again, this is all documented. I have links to the documentation. But what it means is if someone is not, say, a developer who needs these tools, they don't need that. They never see that they even exist. And so you can have a separate, you can have basically a designer version of the editor or an artist version of the editor or whatever, and keep everybody nice and happy, using the right tools, not getting angry, he says. Everyone gets angry, and so on. All right, let's move on to the next thing, which is build health stuff. Sorry I'm going so fast, I want you to have lunch. So first thing I want to talk about in build health is something you hopefully know about, which is size map. One of the things as an enforcer of standards is file size. Why is my project so big? Why is there 2 gigabytes of animation in one file? That was from my Project Titan talk, but is a real thing. Size map just lets you visually see how big everything is in your project and lets you track down low-hanging fruit. Okay, next build health, standards maintaining thing is I want to talk about blueprint diffing. BP diff is a really useful tool. It can be a little flaky at times because the way blueprints are mounted in the editor. But let's say I've got this event trigger that I created. I'm going to create a duplicate of that. I'm going to, I don't know, do something. I'm going to delete some stuff from it because I'm a wild designer wandering around at 1 in the morning in the tool, and I'm like, this doesn't exist. I want it gone. And then, as me, the nice, sensible technical designer I am, I can then say, get both of them and go. Let's go. Tools. Where is my blueprint differ? Let me diff my blueprints. Is it not letting me diff? It is not letting me diff. There we go. Diff selected. So this is the blueprint diff. It's meant to diff everything in the editor. Right now, it primarily works with blueprints. But yeah, I can look at the event graph. Look what I deleted right there. So if you have things that were working and are no longer working, and you don't know exactly what someone did, but you can't roll back because you need to keep some of their other changes, Blueprint Diff is your friend. You should be using it. And if you're not, please start. It is documented. It is useful. The next thing I want to talk about, and this is another standards thing, is validators. So you should be using validators. You can create validator, and they, as the name says, they validate things, meaning when you create a file and save it, it runs the validators on it. You can do them in Blueprint. They're somewhat limited. They're basically for naming, things like that. Because of the way blueprints are mounted in the editor, you can't access a lot of their instance settings. So if I create a blueprint called this is not the right name for a blueprint. Why did I pick such a long name? I don't know. And then I save it, and I look at my message log. I should get is it not warning me? It is not warning me, is it? Maybe my validator's not on. There we go. There's my validator. So if I save it, it is saying my blueprint is missing the prefix BP. That's because I wrote a very simple blueprint validator that runs whenever you save something and just checks if you've named the blueprint correctly. Simpler as going, validate loaded asset, I get its name, I check if it's missing a prefix, BP. If it's missing a prefix, I fail the asset, I put it as invalid, otherwise I put it as valid. Now, there is only so much you can do with blueprint validators. Really, for full validation, you want C++, not Blueprint. And Sam, you're saying, I don't code in C++, or if you're like me, you do, but no engineer is going to take my coding and go, yeah, that's cool, we'll ship that. My colleague Ari has created an entire library of common validators. They are linked from the course material. For C++, in C++, you can plug them right into your project, and then you can check for things like, is this actor on tick? Is this mesh static? Does it have a cold distance? How does its shadow casting work? These are all really important things to do. So before I move on, talking about engineering collaboration, I'm not going to talk about gas a lot, because there is a really good gas talk that you should go to. This afternoon, I think it's this afternoon. You should go to it. If not, it's tomorrow. But you should go to the gas talk about gas for designers. But gas is one of those things where you need C++ to really get it working. So work with your engineers for a clean gas implementation at the beginning of a project. Get your designers comfortable building gas, and your project will become much easier. It's much like enhanced input. Start using enhanced input from the beginning. Don't just have events off direct key inputs. Don't use classic Unreal input. Use enhanced input, because then you can put curves on your input. You can do all kinds of separate rules for your input without doing blueprint scripting. So you should be using enhanced input. That is my enhanced input bit. Use it, please. And then the next thing I want to talk about is, what if I have named this thing the wrong name. What if I have a bunch of them and they're all named the wrong thing? What do you do? Well, renaming stuff in Unreal, as you know, is perhaps the least fun thing in the world. Not my favorite, because what it does is it creates a new thing with that name, creates a redirector, all of that. And so when you're doing mass file renaming, in the past, I would have written something in Python. Unreal has a really good Python plugin. You can write Python tools. I did. However, now, assuming the plugin's on, we have a batch file renamer. I don't know if anyone has noticed. It's an experimental plugin, and it lets me just go add like the prefix BP to all of these files. Bam! And suddenly they all validate because they're all called BP_blueprint as opposed to not being called the right thing. So suddenly you can just mass rename stuff very cleanly. Obviously, mass renaming is a thing you should tread carefully with. But when you're enforcing standards, it is really, really useful to use the batch file renamer. OK, final thing on build health before I move on to sexier things. Are you using Unreal Insights? Hand up people who use Unreal Insights. Yay, those people. The rest of you, I shame you. I don't shame you, but I shame you. It is really, really easy to use Unreal Insights. If you are using pre-built version of the editor, Insights is already built. It's in your binaries folder. If not, it's easy to build with the batch file that comes with Unreal. There's documentation on that. I link to it. Insights is what you use to profile your game. And you want your game to be performant, right? And I'm telling you all these things about here's how to do, here's how to do meshes performantly, all of that. But even so, people might not be working performantly. Then you see this little trace thing down here. This lets you create a trace that you can then run through Insights. So I'm going to start tracing with that little icon. Play the game a whole bunch. In this case, I'm not going to play it for that long because we're running out of time. But yeah, here is me running around in Stackerbot. Pretend that it's not performant. And then I'm going to stop my trace. And then if I open the trace store directory, and then I'm going to open up another folder. Let me go back up here. I have created a little shortcut to Unreal Insights. I can then, look, it's my trace. And that lets you analyze your frame by frame, your project. You can see where there are frame skips. You can see where there are spikes. You can see where there are performance issues. There is a really good talk by Ken tomorrow on using Insights. It is easily worth your time, even if you're not an engineer. People think, oh, I can't use Insights, I'm not an engineer. Use Insights. You will save yourself so much pain when it comes to creating content that runs nicely in Unreal. So next thing I'm going to talk about is future-facing, which is state tree. State tree allows you to add a basically really nice, fully featured state machine to whatever you want. It is not just for AI. And most of the state tree talks, and it's in beta now. It's a plugin, but it's on by default. If you want to do state tree AI, there's a really good talk on that, so I'm not going to talk about it. You should go to the state tree AI talk about the ants. It's cool as hell. I saw it yesterday. If you are doing state tree AI, turn on the gameplay state tree plugin so you can get AI move to debugging, things like that. I want to talk about state tree for gameplay logic. So I wrote an objective system in state tree for Stackerbot. So let me go and drop in an objective. Where are my objectives? Let's just drop that. This is an objective actor that I created. It's got a cute little Stackerbot icon. Objective data. Do thing. I'm going to create an objective in real time. This is just using a struct. Thing. Yeah. Thing done. You did thing. So this is my objective. This is the objective text. You can chain objectives together if you want. Stackerbot, anything you can interact with, has an interaction component. So I can drop in, say, a pressure pad. Where's my pressure pad? It's around here somewhere. Pressure pad. There we go. Pressure plate. There you go. Drop in a pressure plate. Drop that into the world. And all I'll need to do is give it a tag with no, or delete it if you're really smart like me. Give it a tag and call it like Objective1. Tell this what the tag is, Objective1. I hit play. Objective, do thing. I'm going to go do the thing. Bam, thing done. You did the thing, well done. So how does that work? Let me open up my objective actor. State tree. There's a little bit of setup here where it's just finding the things that it's linked to. But the actual objective management is done entirely through a very simple state tree, because objectives are a state machine. They can be completed, they can be not completed, they can be inactive or inactive. So if you've done any behavior tree in the past, you probably are aware of behavior tree tasks. State tree uses state tree tasks. So all I did was create a track objective state, and then there's state tree evaluate objective is the task. If I open that up, what that's doing is basically going, hey, has this been, how many things need to be interacted with to complete this objective? Have they been interacted with yet? If so, complete the task, otherwise don't. And that allows me to very cleanly track the objective, and then if it's completed, go to the complete objective state, which has its own task for completing the objective. If not, go back to the root. And that lets me track objectives with state tree. This is a very simple example, so I could talk about it in the time we have. But let me walk out on the stage. Doors, saving and loading games, loading screens, menus, anything that is state-based. State tree is a solution you should be using, and I thoroughly encourage you to do so. Okay, next thing I want to talk about before I run out of time is cameras. Let me show you something fun. Doo-ba-doo-ba-doo, little happy music. Running around through the world. I'm Stacklebot. I'm running through the world. What's going on? And then I go over here. And oh, look, the camera's changing dynamically. And suddenly, I have a side-scrolling camera. Note that Sam didn't build his H-Lods. Side-scrolling camera with a horizontal dead zone that only moves vertically if it needs to. Oh, look at me picking up coins. How did that work? So I built that with the Player Camera Manager. So it's funny, that's part of the framework. It's been part of the framework forever, but I see so many developers doing all their camera logic in the player controller or the pawn. You have a camera manager for a reason. You should be using it. And there is multiple things you can do with the camera manager. But the key one here is I can completely override the camera that is in the player pawn. The camera manager knows what the camera is targeting and what the camera is called. And there is a function called blueprint update camera. And if you override that, it will give you the camera target, and you can do all kinds of logic. If you want to know how I wrote this camera, check out the template variant for side-scrolling. This is the same camera as that. You can download it right now, and you can play it. But the main thing is it returns location, rotation, FOV, and a bool. If the bool is set to true, it overrides the camera. If it's set to false, it uses the camera set up in the pawn. So you can set up two camera modes very easily, and then transition between them however you want. I wrote a bit of logic to transition them, but in this case, transitioning from a side-scrolling camera to a classic third person. I also have a locked-off third-person camera all built into the Player Camera Manager, and I don't have to do much work to get it going. So the next bit I'm going to give you is homework. We have just introduced a new, very experimental, in the Ludo rewrote it, between 5.5 and 5.6 gameplay camera manager. This is a plugin that lets you basically build camera rigs with a node graph. So you could do a side-scrolling camera, you could do a third-person camera, you could do a top-down camera, and cleanly transition between them to create different kinds of camera nodes, or different kinds of camera behavior. And then you can just say, use this camera, use this camera, use this camera. It will transition. It will trace out to see if it intersects with geometry and swap the material in the geometry to something you can see through. It does a lot of what I think of as advanced camera behavior for you. It's very early, it's very experimental. It's one of the reasons I'm not demoing it today, because it'll take a lot of hand-waving. But as a tech designer, if you're doing future-facing work, if you're starting a new team, start investigating, do your R&D on that, and you will be very happy. Okay, I am clearly about to run out of time, so I am going to tell you one more thing. And then I'm going to let you go have lunch. You may have noticed when I was running through this My Cute side-scrolling platform area, I was picking up coins, and the next coin was appearing in turn, even though when you're in the map, you see all of them, and they are PCG generated. How am I doing that? Very simple. When you may note, I forgot to talk about this earlier, so I'm talking about it now. But what you're actually doing is using the fact that when you spawn something in PCG, you can spawn an actor instead of a mesh, and I am spawning coins as an actor, and then you can tell it how you want it spawned. So with a mesh, you can merge them if you want. Don't merge blueprint actors, it will turn them into static meshes. But you can also tell it how you want it to attach. So I am just simply going attach to the spline that you're being spawned on. And then if you go into the pickup spline actor, what I'm actually doing is going, OK, let's find every energy orb that is attached to this spline. Let's sort them by distance. Let's hide all but the first one. And as you pick them up, just show the next one. So even though it's PCG, you can run full gameplay logic on it. So at this point, I am entirely out of time. I cannot take questions. Please find me in the dev lounge. I'm sorry this went really fast, but I hope you learned some useful things. And if you want any further information, where did it go? Then I have a QR code I can show you. There it is. Here is my QR code. Take a screenshot of that. This will link to tons of documentation about all the things I speed ran through, so you know them, and then you use them in your projects. Your teams will thank you, your developers will thank you, and your end users will thank you, and your game runs way better and plays way better because you provided appropriate standards, tooling, R&D, and support to your project. My name's Sam. Thank you so much.